Hi everyone, how are you guys doing? First of all, welcome back to the Unacademy JEE English. This, as you know, is a brand new channel by Unacademy, which is India's largest online learning platform for IT JEE. And on this particular channel, every concept of physics, chemistry, and maths are being taught to you completely in English. Now, this is a series that I host for class 12 students, and the topic that we are discussing right now is ray optics. This is lecture number 3 of ray optics, and today we'll be talking about curved mirrors. All right. So before we get started with today's discussion, let me introduce myself for those of you who might not know me yet. So my name is Rohit Dixit and I studied mechanical engineering from IIT Delhi. Now for past almost 8 years, I have been teaching physics for IIT JEE Mains and advanced exams. Now all this teaching so far had been offline, and this is the first online venture that I have delved into. Now as a student, I myself was All India rank 447 and All India rank 192 in the two stages of the IIT JEE exams that I took. Then I also qualified the NTC Stage 2 as a student, and I was in the top 1% in the NSCP also. I've already coached many students to top ranks in the IIT JEE exams in my offline experience. Now I hope to continue doing that with you guys here online. All right. So a lot of you guys, I'm sure, must have been a lot troubled with the current situation, and all of us were forced to adapt in the last year. So a great option for all you students is to get yourself the Unacademy subscription. This subscription will give you benefits like live classes where you get to interact with your educators. Then you have live polls and leaderboards in these classes. You also have test series and analysis sessions, and you have regular doubt clearing sessions. So, for those of you who are not aware of this, so every fourth session of the Unacademy Plus courses is a dedicated doubt clearing session. So after every 3 teaching sessions, one session is given to you completely for doubt clearing. Okay, where you can ask away all your doubts. They may be related to theory, they may be related to problem solving, anything that you have any doubt about. So this will ensure that your doubts never pile up and your doubts are always taken care of. Now, along with all these benefits, an academy subscription also gives you the opportunity to study from the topmost educators all across India from the comfort and safety of your home. So that's a wonderful opportunity, I think. All right, and how to get these benefits and how to make use of these opportunities. So what you can do is you can install the Unacademy app. That's the first step. The moment you do that, you unlock yourself a lot of features like free courses. So you can enroll in these free courses. A lot of free courses are running there on Unacademy app for which you do not need to buy the subscription. You just need to install the app. Then you can also take part in special classes. You can attend these. So special classes are free classes that every educator almost takes. So like I take roughly 3 free classes, special classes every week. So you can be a part of those classes. You need to install the app. You can find me there, follow me. You will get all the notifications of these special classes I have got planned, and you can be a part of those then. And of course, on top of this, you can take part in quizzes, the one we just had. Okay, so these are the free features that you can unlock just by installing the Unacademy app, and you can unlock all these features by this code using this code RD Live. Okay, that will help you unlock all of these wonderful free features. Okay, now when you have accessed all these free features, when you have attended all the free courses and the special classes, and you realize that you are ready to buy yourself the plus subscription, then this is how you go about that. And go to the plus section of the app, select your goal as IIT and click on that get subscription button. All right, that will redirect you to the payment page where you will have a box which will say, do you have a code? That is where you can use this code RD Live. Okay, you can use this code and get a 10% off on all your subscription fees. So this code helps you save money off on your subscription fees. Now these subscription fees are already very competitively priced. A 12-month subscription roughly comes to about 2,800 a month, and a 24-month subscription comes to about 2,000 a month, which is way less compared to the kind of quality content that you'll be getting here with your subscriptions. All right. Now you can also choose from 2 kinds of subscriptions. You can either go for a plus subscription or you can go for an iconic subscription, and you can also choose a no cost EMI option while making your payments for all plans of 6 months and above. Okay. So let's tell you a bit about the iconic subscription. This subscription will take your ITJ preparation to the next level. And how does it do that? You will be allotted personal coaches. So from a team of experts, you will be allotted personalized coaching you will be receiving, so that you get more individual attention and guidance throughout your JEE journey. Okay, now you'll also be attending a lot of ITJ workshops, receiving expert guidelines from time to time. getting a study planner, and getting test analysis sessions. So all these benefits, along with all the plus benefits, are available. So this is a subscription that is very, very relevant to people who feel the need of getting more individual attention. So that is how this subscription helps you take your JEE preparation to the next level. All right. Now you can also choose from the combo subscriptions. So you can, if you're looking for a one-stop solution for your entire class 11, 12 board and IT JEE studies, then you can go for these combo subscriptions. So you have first subscription combo where you get the iconic subscription for IT JEE and the plus subscription for your CBSE class 11 and 12, or you can go for the iconic subscriptions for all the three. Now the combo starting prices have been mentioned along the side. So this is how at the price at which the first combo starts. This is the price at which the second combo starts. Then you have two more combos available. One is a plus combo for all three. Okay, your JEE preparation, your board preparation. So all three plus. This subscription starts at this, which is very, very reasonable. And then you have the last combo where you get the plus subscription for your ITJ and the iconic subscription for your 11th and 12th. Now this combo subscription starts at 3,900 a month. Okay, so you can choose a combo that suits you. So Mahi, how are you? Good to have you back so soon. Okay, and this will ensure that all your worries of class 11th and 12th for your boards, for your JEE exams or other competitive exams are taken care of. All right. Now another way of judging your testing yourself, judging your standing amongst your peers, and winning a lot of school prizes, including Unacademy subscriptions, is by taking part in the Unacademy Combat. For those of you who know this, this is the most competitive gamified ITJ battle. So you can take part in it live. The J Combat keeps on happening like almost every 2 weeks. The next event is going to happen on the 17th of January. You can enroll now using the code RD Live and take part in that. Do well and win yourself some really cool rewards and prizes as well. All right. So those of you who are following us on the JEE English channel of YouTube can connect with us on the Telegram app also. Don't forget to do that using this link. Okay, so this will ensure that you're getting all the timely notifications and all the timely uh, messages about all the sessions happening here on this particular channel of YouTube. All right, so with all that, let's get started with today's topic. Hi Rajesh, how are you? Today, as I said, is lecture 3 of Ray Optics, and today we'll be talking about curved mirrors. Okay, so first let's talk about curved mirrors, or more generally, they are called spherical mirrors. So what's a spherical mirror? A spherical mirror is a mirror which has the shape of a piece cut out of a spherical surface. So what we do is we have a spherical glass surface, then we cut a piece out as shown here. Here, this piece has been cut out, and then one surface of this is polished. So either the outer surface is polished, so the reflection is happening from the inner surface, or the reflection would happen from the outer surface. Depending on from where the reflection is happening, you can have two kinds of spherical mirrors. So these are concave mirror and convex mirror. So if the reflections are happening from the inner surfaces, then such a spherical mirror is called a concave mirror. If the reflections are happening from the outer surface, then such a spherical mirror is called a convex mirror. Okay. Now, so as I said, there are two types of spherical mirrors, concave and convex. So you guys already know a lot of basics. I'm sure you have studied this in class 10th, but still consider this just as a quick revision, and then we'll be learning some new things also this year. Okay. So if the reflection takes place from the inner surface, then the mirror is called concave. If it happens from the outer surface, it is called convex. Right. Now let's go over, before we start our study of spherical mirrors, we need to go over some terms related to spherical mirrors. So the first important term which we keep on referring to time and again is pole. So pole is any point on the reflecting surface of the mirror. Now for the sake of convenience, we usually take it as the middle point P of the mirror. So it's a 3D thing. So if you consider the middle point, exact middle point, then that is usually referred to as pole. And all the distances are always measured with respect to the pole. So that is the significance. Whenever we are talking about any measurements, all the measurements will be given with respect to the pole only. Okay, so you can see here, in case of these two mirrors, okay, so the pole is the center point here. The center point here, those are what we call poles of the mirrors. Okay, then you have a center of curvature. Now, center of curvature is the center C of the sphere out of which this spherical mirror has been cut. Okay, so as I said, this spherical mirror would have been a part of a sphere, The center of that sphere from which this has been cut out is called the center of curvature. Okay. So again, on for a concave one, you would have a center of curvature here. For a convex one, you would have had a center of curvature here. So these are two centers of curvatures. Then you have radius of curvature. Radius of curvature obviously is the radius of the sphere from which they have been cut. It can also be, uh, I can also call it the distance between the pole and the center of curvature C. Okay. Next, you have aperture. So what is aperture? Now, aperture is this entire region from where the light is going to enter the mirror. So you realize if I have a spherical mirror cut like this, then I will have a circular cross section from where all the light would enter the mirror. Now that circular cross section is what we call the aperture of the mirror. Okay. The line joining the end points of the spherical mirrors, that is what you can say is the aperture. So it will be a circle. Okay. Spherical mirrors would have circular apertures. Okay. Hi Motilal, good evening to you. Hello Rajsi, how are you? Then you have something called a principal axis. Principal axis is the line joining the pole and the center of curvature of the mirror. Okay, so here if you see, this is what you call the principal axis. Here this line and here this. These are the lines that we call or we denote as a principal axis. Okay. Next, we'll talk about the focusing properties of curved mirrors. Now, curved mirrors can actually focus light. So let's consider one incident ray. So like right here. So I'm talking about this ray which is coming right here, and we want to see at what point will it go after reflection. So we consider a ray which is traveling parallel to the principal axis, and we want to analyze where it will land after reflection. So here you have this ray which strikes the mirror at point A, and after reflection it crosses the principal axis at point B. Now, if you take a look at this, now if you join the line from C to the point of incidence, this line, you realize this will be the normal. Agreed? Now, you realize all the laws of reflections would be definitely followed. So, if this is the normal, then according to the laws of reflection, if this angle is theta, this angle will also be theta. Correct? And what you will also realize is that if you see this angle and this angle, these are alternate angles. So this angle is also theta. So now what I'm trying to do is, if I try to look at the triangle ABC, so in the triangle ABC, I realize this length AC, this is equal to capital R. So let's say uh, if this length is some x, then what you realize is this length is R minus x. Agreed? I hope everybody can see that. Now, what I'm going to do is I will simply apply sine rule. If I apply sine rule in this, so you realize this angle is theta, this angle is theta, this is the exterior angle, this is 2 theta, this is 180 minus 2 theta. So can I say in the triangle ABC, what I will realize is AC equals R and BC equals R minus X. Now applying the sine rule, what we get, we will get that R over sine of 2 theta. Okay, because sine of 180 minus 2 theta is sine of 2 theta. Okay, and that would be equal to R minus X over sine of, agreed. Now sine of 2 theta, you know, can be written as 2 sine theta cos theta. So I will say this will become R over 2 times sine theta cos theta, and that would be equal to R minus X over sine theta. What I'm realizing is that this and this gets cancelled, and X is R times 1 minus 1 over 2 cos. Correct? This is what I'm getting. Now you realize if your theta tends to 0, then the x becomes constant. Okay. Or what I'm trying to say is, for all the rays which subtend very small angle of incidences, all of them would be actually reflected and focused on a single point. Okay. So I can say if theta tends to 0, x is equal to r by 2. So what I'm trying to say is, for all such rays all such rays after reflection would pass through B. That is what we call the focus or focal point of the mirror. So I can say all the rays moving parallel to the principal axis after reflection would get focused there. All of them would converge there. Okay. So that is what we call as focus. And this is the focusing property of this kind of a mirror. Okay, so let's just have that. So let's imagine you had mirror, this, okay, with some principal axis. And if you consider many rays which are very close to the principal axis, then all of them after reflection, would actually pass through this point. So that is what we call the focus. All right. So that is the entire idea of focusing of light or focusing property of a concave or a convex mirror. For a convex mirror, the light rays would appear to diverge from that. Okay. So what I can say is for all rays with theta tending to 0, x equals r by 2, hence all such rays appear to converge or focus or get focused, let's say get focused on a single point parallel to principal axis, of course. So that's the idea behind the focus and the focal point. Okay. I hope you are clear about that. You can clearly see from this equation. From this equation, you realize the x, the point of convergence, okay, depends on the theta. However, if theta is kept at 0, then all the rays can converge to a single point. That is what we call the focus of the curved mirror. Okay, so let's talk about that. So first we'll talk about paraxial rays and marginal rays. Okay. So what are paraxial rays? Paraxial rays are the rays which have very small angle of incidence. So these are the rays where theta tends to 0. Okay, that is what we were talking about. So we give them a special name. These are called paraxial rays. Paraxial rays get focused on a point, or they converge on a single point, or they appear to diverge from a single point, as you can see here. So in this case, we are only talking about paraxial rays, please remember. So for concave mirror, they actually converge at a point, and for case of convex mirror, they appear to diverge from a point. That is what we call focus. Okay. Then we have marginal rays. Marginal rays are the rays which have large angles of incidences. So you realize for marginal rays, the points of convergence would be different. Okay. So such rays will not get focused to a single point. Such rays do not get focused on a single point. So when we talk about focus or focal point, we only define that for paraxial rays. Please remember this. Now focus, again, as I said, if the ray is parallel to the principal axis and paraxial, if the rays are principal to parallel axis and they are paraxial, then all of them appear to converge or appear to diverge from a single point. Okay, and that is what we call the focus. And from here, you will know that the distance of the focus from the pole is r by 2, which we can already prove here. Okay, this is what you call focal length. Okay, focal length. It is the distance of the focus from the pole. Okay, or distance of the focal point from the pole. So that is what we have here also, focal length. Focal length is the length between the pole and the focal point, and for curved mirrors, it is always equal to r by 2. Please remember, f is equal to r by 2, where r is the radius of curvature of the curved mirror. And this is defined only for paraxial rays. Let me remind you again, for marginal rays, you will not have single point of convergence. Every marginal ray would converge or meet the principal axis at a different point. Okay. Now, then we also have a focal plane. And now that's the plane passing through the focus and perpendicular to the optical axis, or the is called the focal plane. So this principal axis is also called the optical axis. Okay, now a plane which passes through the focus and is perpendicular to this, as has been shown here, is called the focal plane. So these are the important terms that we needed to talk about before starting our study. Now let's move ahead. Now we will again, before we start the mathematical analysis, we need to establish a set of sign conventions. So this is the standard sign convention that we are going to follow. Please pay attention to this, because most of the mistakes that students do here in case of ray optics is getting these signs wrong. Okay, if you can take care of getting your signs correct, then trust me, the questions are super easy and you will never go wrong with this. Okay, so now along the principal axis, distances are always measured from the pole. Please remember, pole is usually taken as the origin for all reference points. So whenever I'm marking any distances, obviously I need an origin or a reference point. So that is what the pole is going to be treated as. Now the distance in the direction of light is taken as positive and opposite is taken as negative. Okay, so here let's see a case. So here the light is traveling, incident light for that matter. The direction of incident light is taken as positive. Hello Manoj Kumar, how are you? Okay, so let's just add that. The direction of incident light. So if the incident light is traveling towards right, then the right direction will be taken as positive, as you have been shown here, and this direction, left direction, would be taken as negative. Okay. Similarly, even for a concave mirror or a convex mirror, it doesn't really matter. For both, it would be the same. Okay. Now, distances above the principal axis will be considered as positive, and below the principal axis would be considered as negative. Okay, so please remember, whenever I have anything which is here, so this distance will be considered positive, and if I have something here, so this distance will be considered negative. These are the sign conventions. Now, all the formulae, mathematical formulae that we have for mirrors will be true only with the sign convention. Okay, so that is why the sign convention is very, very important. Now, from here, you will also realize that the focal length of a concave mirror would be negative and that of a convex mirror would be positive. Okay, so please remember that. Why? Because for the convex mirror, the focus lies here. For the concave mirror, the focus lies here. So it is right of the origin. This is positive, and this is left of the origin. So this is negative. So let's make a note of that. Focal length of a concave mirror is taken as negative, and that of a convex mirror is taken as positive. So please remember, if somebody tells you that the focal length of a curved mirror, spherical mirror, is positive, let's say 10 centimeters, then you know they're talking about the convex mirror. If they tell you it's negative 10 centimeters, then you know they are talking about the concave mirror. So please remember about these sign conventions. These are very, very important. If you mess up with these signs, then you will get your answers wrong. Okay. Next. So whenever and wherever possible, the light ray is taken to travel from left to right, so that the sign convention coincides with our geometrical sign conventions, okay, which we use in your coordinate geometry. Okay. All right. Let's talk about the rules of image formation then. So the rules of image formation, first of all, you need to know that these rules are only for paraxial rays. So again, in all our study of optics, ray optics, we will only focus on paraxial rays. So let's make a note of that also. During our entire study of ray optics, we only focus on paraxial rays. Okay, we do not bother about marginal rays. Okay, we usually ignore the marginal rays. So whenever I'm talking about an image formation, and whatever rules I'm defining for image formation are only defined for paraxial rays, remember that. Okay. Now, these rules are based on the laws of reflection, and the images can be formed using ray tracing with the help of these rules. So, the idea is, whenever you want to find where the image is formed and how the image is formed, so there are two ways. One is by geometrically finding it, that is, this approach is called ray tracing, and another is by mathematically finding it by using equations. We will talk about that later. So, first, we'll talk about the geometrical method of finding an image. Okay, so that is by following these rules of image formation and using your ray tracing. Okay, so again, image can be formed. Image can be found using two methods: geometrically and then mathematically. So first, we are talking about geometrically. Geometrically, the method that we use is called ray tracing, in which we draw a ray of light incident from the object and then we trace it, how it will behave after the reflection, and the point of incidence or the point apparent point of divergence is what will where will we see the image. Okay, so that is how we find the images using ray tracing. So these are the rules. So first rule is any ray parallel to the principal axis after the reflection of from the mirror will pass through its focus. Okay, so that's the first rule. So that's the first kind of ray that you need to consider. Okay, so whenever you are using ray tracing, we only consider some standard rays. Okay, so that's the first standard ray that we usually consider, a ray which is traveling parallel to the principal axis. You know that after reflection, this such a ray would always pass through the focus, or that is by definition of focus. Of course, it will pass through focus. Okay. Next ray that we need to consider is a ray passing through or directed towards the focus will become parallel to the principal axis after reflection. Okay. Now this is simply by reversibility, principle of reversibility of light. You know that if a ray which goes like this, if it passes through focus after reflection, then reversibility principle suggests that any ray moving like this after reflection would go like this. Okay. So ARJ says, sir, to cover the theory part of heat and thermo, approximately 12 lectures is almost the same as much as rotation, approximately 15 hours. Which one should I go for? Thermodynamics, definitely. Heat and thermo, because that will help you in chemistry also. Okay. And that is easier to understand. It may be time consuming, but it's easier to understand than rotation. Okay. In rotation, even after spending that much of time, you might not be sure, but at least in thermodynamics, you will feel fairly confident. Okay. So that is what I would suggest. Okay. Right. So I hope that is clear. So these are the first two rays that I need to consider for ray tracing. Then I have another set of rays. Yes, yes, of course, AP is absolutely right. So again, another thing is that if a ray is passing through or directed towards the center of curvature after reflection from the mirror, it will retrace its path. Why? Because angle of incidence for such a ray will be zero. So the angle of reflection will also be zero. You know, for normal incidence, any ray that is incident normally will always retrace its path. Also for SHM, do I need anything of rotation? Hmm, depends. Some questions might involve rotation, but in general you don't. In general, for studying SHM, you don't need a rotation. Okay. All right. So this is one thing that you need to consider. And then the incident and the reflected rays at the pole of the mirror are symmetrical about the principal axis. This is simply because the principal axis is essentially normal to the mirror. So obviously, so here you would have a symmetry. If this angle was theta, then this angle would also be theta. So any ray which is incident at the pole would reflect back symmetrically with respect to the principal axis. Okay. Now, once you have this knowledge, you can go for image tracing. So let's take up an example and let's try and trace an image. Okay. All right. So here, generally what we do is okay. So let's draw ourselves a mirror. Let's say here is a concave mirror. Okay. This how you start, and then this are the principal axis. Let's say like this. Okay. And now if I have an object, if I have an object kept on the principal axis, and let's say the object is looking like this, okay, and I want to trace the image of this. So let's draw some points. Let's say I want to first of all mark the center of curvature. Say here is the center of curvature, and obviously at half of this length would be the focus, right? Because f is equal to r by 2. You remember that. Now what I need to do is, for finding the image of this object, so let's take a bigger object first of all. Let's take a bigger object. Okay. So if I want to find the image of this, so first I can consider a ray which is traveling parallel to the principal axis. Okay, so let's imagine I have considered such a ray. After reflection, this ray will pass through the focus, right? The next is I can consider any of the other rays. I can consider one ray that goes towards the focus, and after reflection, I know that this would have become parallel to the principal axis. So that is one ray that I could have considered. Okay, or I could have considered other rays also. Let's see some other rays also. So another ray that I could have considered would be like this. So this ray, which passes through the center of curvature, would have just after reflection retraced its path. Okay, so let's shift the center somewhere here. Center C is somewhere here. So this kind of ray would have simply retraced its path. So that is one. Similarly, you could have even considered another ray which would have gone like this, but incident here and then gone like this. So these are the four rays that we commonly consider. Now, what you realize is that the point of intersection of any of those two rays would have told you where the image is formed. Okay, any of those two, they would have all intersected at one point, and this is where you would have found your image. So you did not actually need to consider all those four rays. You could have just considered any two rays out of these four, and you would have found your image. Okay, I hope that is clear. This is how ray tracing works. This is what we do in ray tracing. Okay, I don't know if the ray tracing thing is. We write it below. So this is an example of ray tracing. Correct. This is how you would have found your images geometrically. Okay. Now let's take a look at some common properties of some of the images formed. Okay, so here we have mirror, then you have object location, then you have image location, you have the type of the image, and you have the orientation of the image and the relative size. So again, most of you must have studied this in class 10. This is just a quick revision of what kind of images are formed from where and which kind of mirror. So if I talk about concave mirror, for concave mirror, if the object is located at infinity, then the image is formed at focus. The image is a real, the image is inverted, and it is almost point size. In fact, not only smaller, but it is almost point size. Similarly, if the object is located beyond C, so beyond C is the example which we have here. So here you would have noticed that the object is placed beyond C. Where do you think the image got formed? Image got formed between C and F. So this is what you will see. Again, you can verify all these results geometrically also, but these are the standard results which you can simply remember. Okay. So if the object is placed beyond C, then you realize that the image is formed between F and C. The image formed is real, it is inverted. Again, you can notice both these things, and it's smaller. You can in fact notice all these three things. The image formed was real, it was inverted, and it was smaller than the object. Okay, I hope you can see all these 3 points here. Inverted image, real image. Why? Because the rays after reflection are actually converging to that point. Okay, so that is why you have a real image. And then of course you can see the image is smaller. It is formed between C and F, and it is smaller. So all these three things can be verified. In fact, all these results can be verified with the help of ray tracing. Okay. Now, if the object was located at the center of curvature, then the image is formed at the center of curvature itself. It is real and it is inverted. Okay. Now it is of the same size as that of the object. Again, if your so as your object is coming closer from infinity, you realize that the image is going farther from f and it is becoming larger and larger. At f, it is almost negligible size. As you move away from f, as the image moves away from f, its size also becomes larger and larger. At c, the two are exactly of equal sizes. Beyond C, if the object is there, then the image is smaller and it is beyond this side of C. When the object moves on this side of C, the image moves on the other side of C and it becomes larger. Okay, so this should be easy to remember. So when object is placed between C and F, then obviously the image is formed beyond C. It is real, inverted, and larger. Enlarged image you will see. Okay. Then if you have the object at focus, then theoretically the image would form at infinity. Okay, now, sir, if I know wave optics, will it help in waves? Okay, yes, yes, a little bit. Because in waves, you also study interference, no? So it will help you understand interference. However, phenomena like Doppler's effect and beats, they are related to sound. Okay, so there, your knowledge of wave optics will not help much. Okay, Ananya. But as far as interference is concerned, that thing you will get help with. Okay, but the ideas of waves at least you would know, right? Then, if the image is, if the object is placed between F and principal and pole, now this is a special case, then the image formed is behind the mirror, it is virtual, it is upright, and it is larger. Okay, so this is a very interesting case. Again, you can verify this using ray tracing also, so not a big deal. All right. Then for convex mirror, it doesn't matter where you place the object. You place the object anywhere on the entire principal axis. The image is always formed behind the mirror. It is always virtual, upright, and smaller. So these are the properties of the images formed by convex mirrors. Again, as I told you, all these can be verified using ray tracing. Okay, you can verify all these. Now we will talk about the mathematical approach of finding out the image position. So for that, we will focus on this triangle. Okay. Let's focus on this triangle. Let's imagine that you have an object here. So I have considered one ray that leaves the object like this, and after reflection, it goes like this. And if you consider another ray which is going like this, okay, incident just like that on the pole. So after reflection, you realize it will come back, and these two rays you realize are intersecting at this point. So this is where you would have had the image, which has been denoted as I. Okay, the object is denoted as O. Now let's consider this triangle. Okay, so the ray strikes the mirror at point M, and the angle of incidence is theta. The angle of reflection will again be theta. Okay, and C is the center of curvature. So obviously the line joining C and M would be the normal, and that's why the two angles are equal, right? Now, what you need to do is take a look at these angles. Okay. So, if you take a look at these angles, so you will realize that this angle beta is an exterior angle of the triangle OCM. Correct? Let's write that for triangle OCM, beta is equal to the exterior angle. Right? Since it is the exterior angle, what I can say is I can say beta would be equal to the sum of the two interior angles alpha plus theta. Okay, that you should be able to see from here. Okay, that beta would be a sum of this angle and this angle. Okay, now let's take a look at the triangle OMI. Okay, similarly, I can say similarly for triangle OMI, what I'll realize is gamma, the exterior angle. Okay. So what I can say is gamma would be equal to alpha plus 2 theta. Correct? Again, let's go through this and see this. So for the triangle that I talked about, this is the triangle. This is slightly thinner. So this is the triangle that I'm talking about. Now for this triangle, you realize gamma is the exterior angle and gamma would be equal to alpha plus 2 theta. Correct? All right. Now comes the question that I wanted to choose. I wanted to choose all the rays which are paraxial. So if the rays are paraxial, then what you notice is that the point of incidence, this height should be tending to 0. If this is h, if this is h, then the h tends to 0. Okay, for paraxial rays. For paraxial rays, they are incident very close to the pole. So I can write, so for paraxial rays, or for rays to be paraxial, for rays to be axial, h tends to 0. If h tends to 0, so I can say alpha tends to 0, beta tends to 0, gamma tends to 0. Okay, all these angles will tend to 0. Now, what I can say is from equations 1 and 2, from 1 and 2, I can eliminate theta, right? I can eliminate theta and I can say that gamma would be equal to alpha plus 2 times beta minus alpha, or I can say gamma is equal to 2 beta minus alpha. Correct. Now, since I have taken the paraxial approximation and since alpha tends to 0, beta tends to 0, and gamma tends to 0, so what I will say is that since alpha tends to 0, I can say alpha is roughly equal to sine alpha, okay, which is roughly equal to over h over this distance. And I will say that if h tends to 0, this also tends to 0. This d also tends to 0. Okay. As you move closer to the pole, you will realize if you move closer to the pole, this distance is decreasing. Okay. I hope you can see that. When comparing these two, if I compare this ray and this ray. So as you're moving closer to the pole, you realize this distance is also tending to 0. So if h tends to 0, if h tends to 0, so you realize d also tends to 0. So let's write that here. If h tends to 0, d also tends to 0. D is this distance. Okay. So what I can do is when I need to write sine alpha would be h over this distance, and this distance can be roughly taken as u only. Okay, so I can write this as h over u. Now, if I include the sine, the u would have had a negative sign, so the length would have been minus u. Okay, why am I adding a minus sign? Because if I use u with proper sign, u would have had a negative sign, so the length would have been minus u. Okay. Similarly, what I can say is, how about beta? Beta would be h over r, and gamma would be h over v, where v is called the distance of the image from the pole. Okay. Now, once I know all of these three things, again, I will have negative signs, because again, the radius of curvature and the v both are lying on the left hand side of the pole. So all these values would have had negative signs. So the lengths to be considered would have a negative sign with them. So replacing all these values here, what I will get is, therefore I can say h over minus v would be equal to 2 h over r minus r. Then I would have had plus h over 2. Okay. You can cancel out all the h's, and what you will realize is that 1 by v plus 1 by u equals 2 over r. So this is the relation between u, v, and f. This is called the mirror formula. Okay, so this is called the mirror formula. And mirror formula suggests that 1 over v plus 1 over u equals 1 over f. Okay, very, very important result. This is what we are going to use mathematically to find the position of the image if the position of the object is known and the focal length, of course, is known. Okay. So please remember a few important points again. Use with proper science. Okay. Now, though I derived this for a concave mirror, it works for convex mirror as well. That's my second point. Works for convex mirrors also. Now, and third and the most important point, valid only for paraxial rays. Valid only for paraxial rays. You realize in that derivation, I have assumed, I have taken the assumption that the angles are tending to zero, right? So that is what you need to remember. Very, very important points. So this mirror formula is very, very important, first of all. You need to memorize this. Memorize the mirror formula. And then, of course, you need to memorize these points. That use the proper signs will work for convex mirrors as well and valid only for paraxial rays. Okay, so paraxial approximation is there for the entire duration. Okay, please remember this. All right. I hope everybody is convinced with that. Now, this is how we will mathematically find our image positions if the object positions are known. Okay. Now, why don't we have a practice problem? So, with that practice problem, I will wrap up today's session. Okay. So here you've been told, okay, so I'm taking a complex one. I'm not taking the easy one because a lot of easy problems you guys have already solved in your class 10th, right? So if I took straightforward questions, so that would have been too easy for you guys. But you guys would have felt bored. All right. So that's why I got this slightly complex problem. It says a concave mirror of focal length 10 and a convex mirror of focal length 15 are placed facing each other 40 centimeters apart. Now an object is placed between the mirror on their common axis and 15 centimeter from the concave mirror. Find the position of the image produced by reflection first from the concave mirror and then at the convex mirror. Okay, so try this, try this. I hope the situation is clear. So let's make a diagram also just in case the situation is not clear. So the concave mirror is there and it has a focal length of 10. So you have a concave mirror here and you have a facing convex mirror. Convex mirror that is facing this. Okay, now you can join the line and this is the common principal axis. Okay, so the distance between these two is 40. Okay, so this has a focal length of so let's use minus 10 centimeter. This has a focal length of plus 15 centimeter. Okay, all right, or let's just not write the plus minus right now. I'll tell you why. These are the focal lengths of the two mirrors. Now you've been told that the distance between these two, this distance is 40 centimeters. Okay, now an object is placed on the common axis 15 centimeters from the, here is where you're putting the object. It is at a distance of 15 centimeters from the concave mirror. You have to find the position of the image produced by reflection first from the concave mirror and then from the convex mirror. Okay, where do you think that image will be? Okay, so first, what will happen is that this will form an image. Okay, so let's say the image is formed somewhere here because this, if you realize, is lying between F and 2F. Okay, so F and C. So the object is between F and C. So where would the image be? Image would be beyond C. So let's say somewhere here the image is formed I. Now you realize this I will behave as an object for this mirror. And then this mirror would form another image eye dash somewhere here, which would be the image of this eye. So that is what you have to find. You have to find the location of eye dash. Okay, I hope the question is clear to all. Huh? So how do we get this? Anyone trying? Let me know. If you're trying, then I can wait for you. Otherwise, I'll solve this. Since this is the first question that we are tackling, I'll solve this. Hmm. Again, if you are trying, if you want to try this on your own first, you can let me know in the chat. Otherwise, I will solve this. Or why don't I do one thing? Let's give this question to you as homework. I will discuss the solution in the next class. This is your homework problem. You can calculate and leave your answers in the comment section. Okay. Leave answers in the comment section. And I will discuss the solution for this in the next class, okay, because we are already running out of time for today. All right, so try this, try this. I would want you guys to try this. I've already told you the hint. I've already drawn the situation. This is what the situation looks like, okay, and how to go about it. Okay, this should be an easy one. Okay, all right, we'll discuss the solution in the next class. So before I wrap up today's lecture, let me remind you one more time. If you haven't gotten your Unacademy subscriptions and you're planning to, this is how you do it. Go to the plus section of the app, of your Unacademy app, select your goal as IIT JEE and click on that get subscription button. Now, when redirected to the payment page, you will have a box here which will say, do you have a code? So that is where you can put this code, RD Live. This code will give you a 10% off on all your subscription fees. All right, and you can now choose from two kinds of subscriptions, Plus or Iconic. And when you click on Proceed to Pay, you can also get a lot of options of choosing a no-cost EMI option. Okay, so you can break that payment also. You don't have to make that payment one time. You can break it into a lot of no-cost EMI options, which will ease the burden of that payment as well. Okay. Now, telling you about the Iconic subscription, this is a new feature being provided by Unacademy. So this is a new feature that has been presented to you for students. So this subscription will take your IIT JEE preparation to the next level. This will help you with personal coaches. So there'll be personal coaches allotted to you who will guide you personally and mentor you closely throughout your IIT JEE journey. Plus, you'll be receiving benefits like IIT JEE, regular IIT JEE workshops, receiving expert guidelines, getting a study planner, and getting test analysis sessions. So these features will again help you for a better and smoother sailing of your IIT JEE journey. Next, now you can also go for combo subscriptions. Okay, so now if you're looking for a one-stop solution for your entire worries of class 11th and 12th, so that is your 11th school exams, your 12th board exams, your JEE mains and advanced exams, so you can find a combo subscription which will be a one-stop solution for all your worries. So there are four kinds of combo subscriptions currently available. So one combo subscription gives you the Iconic subscription for IIT JEE and the Plus subscription for 11th and 12th CBSE. Another one provides you all three Iconic combinations. Next one provides you all three Plus combinations, and then you have a Plus subscription for IIT JEE and Iconic subscriptions for your CBSE 11th and 12th. You can choose from any of these subscriptions that you feel comfortable with, and the prices mentioned are as follows. Next, you can also for a competitive exam like IIT JEE, regular testing and regular self-analysis assessment is also very, very important. So a great way of doing that is by taking part in the Unacademy JEE Combat. Okay, so you can do that. So that will get you a good practice, a good test of your understanding and knowledge. It will show you where you stand in comparison to your peers, okay, and how you're doing well there. Okay, and of course, if you do well, you will win a lot of rewards and prizes. Okay, so Rachit Pandya says pre-boards marks are added in CBSE. No, no, they're not. They're not. Pre-boards are just practice for you. Okay, those marks are not added. Your practical marks are added, of course. Okay, those marks are not added. All right. Okay. So again, the next event is going to happen on the 17th of January. You can compete live in that, and you can enroll now using the code RD Live. Okay. use this code, enroll in that, do well, and you can even win yourself the Unacademy subscriptions. Okay. Next, if you've liked this today's session, then do not forget to press the like button. And so I've seen a lot of you guys do press that like button, but not sharing it. So make sure you share it with all your friends also, so that this completely free of cost quality content reaches as many students as possible. Okay, so we understand that not all students can afford these subscriptions, so every student should however still get a chance to get access to quality education. That is why we have this channel. That is where we are providing completely free of cost education, okay, quality content which will help you with your JEE and boards also. Okay, so make sure you're sharing it so that more and more students can benefit. Hello Chandra Joshna, what happened? Why are you, what are you sorry about? Also, if you're new to this channel, don't forget to subscribe, okay, and press the bell icon to keep receiving timely notifications of all the lectures and sessions happening here. And the PDF of all the slides used in today's lecture will be available for download very, very soon. All right. Next, if you're following us on the JEE English channel of YouTube, you can connect with us on the Telegram app using that link, so that you are aware of all the sessions and lectures happening here on this channel of YouTube. Okay. Sir, I want batches and year-long courses in English language. Okay. Yeah, unfortunately enough, right now there are no year-long batches and courses in English language. Yes, I understand. I will convey this to the team, Unacademy team, and let's see. Okay, I will try to make it happen. All right. Next, all right. Before I leave you, finally, let me remind you one last time. This is my code RD Live, so you can use this code to get your Unacademy subscriptions and enjoy a 10% off. So we will carry forward with the discussion on curve mirrors in the next class, which is on Thursday. Till then, you guys keep studying hard, keep practicing, and take good care of yourselves. Okay, Chandra Joshna. So I will take up your concern with the Unacademy team, and let's see what can happen. Okay. All right. Take care. Bye bye.